Perfect. Shh. We are going to take notes on 2.2. Everything that you learned in 2.1, you still have to know how to find a derivative using limits. But there is an easier way. If I was trying to find the limit or the derivative, if I was trying to find the derivative of this function, the original function is 3x squared plus 2x plus 1. There is a pattern that goes with finding derivatives. We are going to write down that rule in just a second, but let me just show you what the actual derivative is. Without using the limit process, I'm going to use something called the power rule. The power rule. And using the power rule, the derivative of this equation, I kind of feel like I should write it below it just because we've been using stuff like that. The derivative would be 6x to the first plus 2, and that's the derivative. That's how fast it will be for you to find derivatives now.
Dang.
Okay?
Yeah.
Okay? So, if you don't know how I found the derivative, we're going to write down the rule right now. It's called the power rule. So I'm going to write it right here. The power rule is this: d over dx of x to the nth power is equal to n times x to the n minus 1 power. This is the power rule.
This sounds beautiful.
Looks confusing.
What are you talking about? I like my way back. Yeah, I understand this completely.
Okay? Let me show you what this means. If I'm trying to find the derivative, d over dx means I'm taking the derivative with respect to x. That's all that d over dx means. It means if I want to take the derivative of x to the nth power, all I have to do is take the power, multiply it in front of the x, multiply the power in front of the x, and then subtract 1 power. That's what that means. Let me show you what that means on the problem I just did. It means that if I want to take the derivative of this, I take the power, the n, I multiply it to the thing that's in front, multiply it there, and what did I get? 6, and then I subtract 1 power from the exponent. That's the derivative. That's the power rule. I did the same thing here on this 2x. What's the power of the 2x? What's 1 times 2? And then what happens when I do the first power take away 1? It becomes x to the 0 power. What is x to the 0 power?
1.
And so that actually became 2 times 1. Did I write it down? No, it just 2 times 1 was 2. Okay? And then let's say that I have x to the 0 power. Okay? And I have x to the 0. 0 times 1 would be 0. And that would just basically mean I'm adding nothing. So using the power rule, it brings up another rule that we should know as well. When I take the derivative of a constant, if I take the derivative of pi, or I take the derivative of 2, or the derivative of -7, a constant, that's what this means, a constant. The derivative is 0. So remember how I had this 2x plus 1? The derivative of the plus 1 was 0. Did I have to write that down in this case? No, because there was a 6x plus 2. This is the power rule. The power rule is very, very nice. Let me have you practice, and then I'm going to tell you its limitations. Here is the first practice problem for you to try. Let's try 16x to the third minus 12x plus 7. Find the derivative of g of x. find g prime of x.
Do we have to factor
Oh,
after that?
sounds quick.
We have to like factor it after? Where is it?